All right, this is the first assignment, the array-based deck for Comp 251, Donovan Unruh. So first things first, we have this right here. So the way I did it is I have front and I have count. So my thoughts was count just counts the amount of elements in the deck, and front points at the location in the array that the front is located. So of course, if it's an empty deck, front will be at 0 and count will also be at 0 because there's no elements in the deck yet. Um, yeah. So here we have my expand method. So simply enough, it takes the max size, which starts at 5, multiplies it by 2, grabs a new temporary deck with the new max size, and then I have a loop here that grabs the location starting at the front and moving along and just inputting in the, just cycling through the array as if I were emptying it one by one starting at the front. And then it returns the temporary deck. And again, simply enough, with the size, it just returns the count because in my code, I have it keeping track of the count as it goes along. So it should always be true. The count should always be equal to the amount of elements in the array, or at least the amount of valid elements in the array. Clear, you just set count in front to back to 0. And basically what that does is the array that no longer saves or considers anything else in the array as valid. So carrying on. And if count is 0 for the isEmpty, it returns true. If it's not 0, it returns false. Again, simply enough, count follows along with all the other stuff in the code. And moving on to add first. The first thing we have to do, because otherwise it won't be, we'll end up running into errors, is we have to check to see if the array even has any space left to put in elements. So count, if it's equal to max size, we have no more space left, so it has to expand. So we call the expand function that I went over earlier, and it goes through that with a bigger, and now we have a bigger deck, and we have to set front to 0. We have to set front to 0 because when we call this function, it doesn't set front to 0, and it's if we don't set it to 0, we can have front at 3 or 5, and that won't be the front of our deck anymore because with this method here, it would place whatever was at the front of the deck to element 0 of the new array. So because of that, we'll have to set front to 0. And then after that, we can start putting stuff into the array. So if it's empty, we just set deck, the 0th term in the deck to x, front to 0, and increment count. However, if front is 0 and it's not empty, then we take max size, -1, and then increment count. The reason why we do this is because if front is at 0 and we take away 1, we end up getting -1, which doesn't work in an array. So this is one way we can do it. And then if front is not 0, we just decrement front by 1, put an x, and increment count. And if we want to add a element to the end of the deck, again, first thing we have to do is check to see if the deck is full. If it is, we do the exact same thing as we did before. And here, this is a little bit more of a much more elegant way of typing it. So we add both count and front, and we do ampersand max size. What this does is if our size is 5 and our count is 1 and our front sorry, if our count is 3 and our front is 2, you add them together, divide it by the max size. In this case, the remainder will be 0, and then we would input the element into 0, which would be the next point in the array. And we increment count by 1. And to remove first, what we do is we take the front element. The front element will always be, or the first element, I should say, will always be in the front index. So if front is at 5, the fifth index of the array would be the front of the deque. So we could just do this, save the element. We increment front by 1, so we shift it over 1, and we decrement count because we're removing that item, and we return the item just in case we wanted to use it. Again, similarly with count, with remove last, but reverse. We grab an item, we decrement count, add front, and add percent from max size. And then we return the item. And for getting a arbitrary index, what we can do is we add the index to the front and we divide it by max size. The reason why this works, it's similar to the when we are getting the end of the element. So we're getting like the last element. Hold on, we actually have to do -1 here, I believe. When we're getting a random element, we add both the index and the front to each other, and then, all right, let's just say we have front is 0, and we want to get the first index. So to do that, we just add 0 to 1, and we divide it by, or at percent it from the max value. So let's just say if it is 5, we add both of them together, divide it by, or at percent it by 5, and we get index 1. So that's why this code here works. And similarly, in the same vein, you do the same thing with get last, but this time you have to subtract 1 from it because count isn't written. If count is at 1 and front is at 0, if you're trying to get the first element and you add count and front, you'll end up getting the first element, like the index 1 of the array rather than index 0 of the array, which is what you want, because count starts at 1 and indexes start at 0, which is why we have to -1 in this case, but not this case. Carrying on, simply enough, to get the first index, you just put in front into the array, and because it's written in terms of the indexes, so that'll be simple enough. And to turn the array into a string, I used a for loop. So it just increments itself through the array, placing one item at a time into a string I called item, and it just places a space between the items, grabs an item from I, adding it to front, and dividing by max size. So basically what that does is it starts at front and then slowly moves to the right. And if it loops around, the at% max size brings it to the front. So like for example, if front is here, the fully black arrow, and the end of the count, the end of the array is the white and black arrow, it would slowly, one at a time, it would start here, and then next it would go here, and it would go all the way around, going one at a time through each index until it loops all the way around to here. And eventually we'll get the entirety of the string would be each element of the array starting at whatever we indicate the front to be. And then I return the bracket here plus the item with another square bracket just to make it look all nice. So to see if this works, there you go. So I run my code and all the asserts pass. We call the test string. It adds all these, and as you see here, Jason, Sarah, Miriam, David, John. Jason, Sarah, Miriam, David, John. We go to the next one. Sarah, Miriam, John, David, Jason. Sarah, Miriam, John, David, Jason. And we go to the last one here. Chris, Bala, Sarah, Miriam, John, David. Chris, Bala, Sarah, Miriam, John, David. And we go over here. The output of the integer should be 20, 40, 50, 30, 10. 20, 40, 50, 30, 10. And the last one here, it should be an empty array. There you go, empty array. So that is the implementation of my array-based deque. Again, my name is Donovan Unruh. This was the array-based deque for comp 251, and that is all.